All right, let's go and get started. Page 158 in your textbooks, you had 4 problems to do for homework. Was all page 158, review 1 through 7, the odd. Of course, did also encourage you to spend some time studying over the many terms and notes that I've given you in this new section. Homework, of course, had nothing whatsoever to do with our new material. Find it quickly. I'll come back to you. Oh, got it? Excellent. Bueno, and bueno. All right. Well, let's start by reviewing over some first semester concepts. We have this equation that is in quadratic form. It's set equal to 0. Kendall, what do we need to do next?
You can add this one.
Good. We need to factor it, right? And when we factor, we get?
You get x cubed and x cubed. The signs are negative. And then 2 and 3.
There we go. Either way, 2 or 3, 3, 2. Either way is fine. And then we would take these factors and do what, Maddie? To get 2 little equations, right? What would those be?
X cubed equals 2, x cubed equals 3.
At this point, Genesis, I don't want x cubed. I just want plain old x. How do I get rid of a cube? Take the cube root. Of course, what we do to one side, we'll do to the other side. So we'll take the cube roots of all of these. And that ends up giving me, what 2 answers?
X equals 8.
Oh, okay, we're cube root of 2, right? So not 2 cubed for 8, but literally just cube root of 2, and then also... And there are our answers. And notice how many answers should we expect, class? 6. 2 of them are real, though irrational. The other 4 are complex. And as I said before, you're not going to be able to find those yet. Okay, you have to wait till senior year to learn how to find those. How many have these 2 answers, these 2 roots of the equation? All right, questions on this? All right, so some of you tried to shake the rust off of Christmas there. Had some people who maybe struggled there. This next one's really very similar if we'll take the time to rewrite 1/4, Michael, as...
1/8. 2/8.
2/8, there we go. So we just think of this 1/4 power as the 2/8 power. It's now in quadratic form, and we can backwards FOIL it just like Kendall did on the last one, Michael.
Let me see what I put down. X to the 1/8 equals minus 2. And then x to the 1/8 minus 1.
Good. X to the 1/8, x to the 1/8 signs are both going to be negative. We'll split the 2 into 1 and 2. Outer inner checks. Once again, we'll make 2 little equations, Audrey.
X to the 1/8 equals 2, and x to the 1/8 equals 1.
Now in this case, again, I don't want x to the 1/8, I want x. When we had an x cubed, we took the cube root. When I have an x to the 1/8 power, what do I have to do, Brandon, to get just x's? Raise to the 8th power, because you're trying to cancel away 1/8, or technically remember 1/8 power means the 8th root. So these are already roots, I need to raise to power. These were already powers, I needed to take roots. So we're going to raise to the 8th power here, here, and here, and we end up getting x is equal to what 2 possible solutions here, Abby?
256 and 1.
256 and 1. Really ought to check both of those solutions. The 4th root of 256, of course, is 4. The 8th root of 256 is 2 times negative 3 is negative 6. Plus 2 equals 0. That checks. 1 to any power is just 1. 1 times negative 3. And we notice they both check. I already had a good idea they would both check because I did not do what? That often creates extraneous roots, anyone? Raise a negative to an even power. I didn't do that, right? So nothing went from a negative to a positive or anything. So I was already pretty sure both answers would check, but always good to check. How many had those 2 answers on number 3? All right, questions on this one? All right, looking at the next one, we've got this binomial raised to a fractional power here, Kendall.
You raise it to 3/2 power.
Good, raised to the reciprocal power, remember? And, of course, the 3/2 and the 2/3 cancel. So here, of course, I'm just left with...
W equals 2.
But Maddie, how could I literally read 25 to the 3/2 power? What does that mean?
25 squared to 1. I mean, you know, yeah.
I do. I want to try to see if you do.
25. The square root of 25 cubed.
Perfect. There we go. The square root of 25 cubed. It's okay. It's since Christmas. Right? Square root of 25 cubed. But we know that the square roots of 25 are what?
Positive negative.
Positive negative 5. And we're going to cube both of those to get
Positive negative 25.
And then to finish solving for the w, Genesis, we need to...
Subtract 2.
All right, so if I have a 125 and I subtract 2, I get...
123.
And if I have a negative 125 and I subtract 2...
Negative 125.
Well, I have a negative 125 and then I have to take away 2 more, or negative 2 more. Would give me negative 127. There we go. And should have had these two answers on number 5. And how many had those two for number 5? By the way, so, anyone forget the positive, negative? You just had the 123. That's what the book did as well. So one time in which they were wrong. All right, questions on this. And looking at the last one, this was by far the hardest one. It's a rational inequality. And I said the first key to a rational inequality, Michael, is you got to set it to 0. So I've got to move either the fraction over or the 3 over, and you chose to move the 3. So that's going to give us our x plus 2 over x minus 7 minus 3 less than or equal to 0. My exhortation was when you bring it over, put it over 1 so that you can see it as a fraction, because my next key is to turn all of this, both terms, into one single fraction. So Audrey, when I turn it into a single fraction, the common denominator is going to have to be
X minus 7.
because it's the only denominator, right? Well, this already had an x minus 7. So does anything need to change in the first fraction, class? No, it'll leave the x plus 2. But here it didn't have a denominator of x minus 7, it just has the understood 1. So to get an x minus 7, of course, I've got to do what with the 1? Brandon?
Multiply by x minus 7.
Yeah, multiply by x negative 7. But what we do to the bottom? So we're going to multiply the top by the x negative 7, also getting what numerator from this fraction as we copy it down, Abby?
Negative 3x positive 21.
And of course, we want to combine some stuff up here in the top. What does my numerator combine to, Abby?
Negative 2x and positive 21.
All over an x negative 7, all less than or equal to 0. Once we have a single fraction set to 0, now I can get my separator points. My numerator is going to give me some separator points, remember, and the denominator will give me some as well. Well, the denominator separator point's the easiest one, class. 7, right? Because you just set it to 0. So 7's my numerator, or my denominator separator point. My numerator separator point, when I set this to 0, I'm going to send the 2x over as a positive and then divide away the 2 to get what unfortunate numerator separator point, Kendall?
11
Well, you could say 11 and a half. I'd rather say 23 halves because I'm lazy. But practically speaking, yes, that's 11.5. Okay, if we wanted to think of it that way. So 2 separator points. Now, as I look at the original inequality, I've got less than or equal to. The or equal to normally means my separator points, class, are going to be, well, if I were to do, I'm going to use brackets versus parentheses, but on the number line I would use a closed dot. But remember we said the denominator separator point always gets open circle regardless. So this is a closed dot, this is an open circle. That is to say, this is going to be bracket, this is going to be parenthesis. Now, as far as on the number line, 7 is going to hit before the 23 halves. So if I wanted to draw a quick number line here, okay, here's 0, that's not a separator point. My 7 is the first separator point I come to, and then the 23 halves shows up a little later. So I get 3 ranges of values from these 2 separator points. Genesis, what are my 3 ranges of values? Well, remember, 0 is not a separator point, it's just these 2. To 7, good.
7 to 23 halves and 23 halves to 1.
There we go. And on the infinities, of course, Michael, we always use what notation?
Parentheses.
And on the 7, we're also going to have to use the parentheses, remember. But on the 23 halves, we can go ahead and use the bracket. And it just comes down to test values. Some random value between negative infinity and 7, anyone?
0.
I love that value. Something between 7 and 23 halves. 8, 10, either would work. I'm actually going to go with 8 because I see what the denominator is. And though 10 wouldn't be too bad, I guess. And then something bigger than 23 halves. 12. All right, so if I plug in a 0, of course, these 2 numbers drop out, and I get negative 2 sevenths. Is that smaller than 3, class? If I plug in an 8, 8 plus 2 over 8 minus 7, 10 over 1 is 10. Is 10 less than 3? All right, I didn't expect it to work. I do expect the 12 to work. 12 plus 2, 14. 12 minus 7, 14 fifths. Is that smaller than 3? Just barely, right? But it does. Check out. So there's my answer. I'm curious. This was by far the hardest problem. How many got that answer? Maddie, fantastic. How many at least got the separator points, the 23 halves and the 7? Okay, Genesis, good. All right. The rest of you, we forgot over Christmas break. This was something that we hadn't worked on in a long time. We worked on it for what, a couple days before we started exam reviews, and of course did it a little bit in the exam review. Questions on this? Okay, hopefully jogs your memory just a little bit. Well, let's take a radical transition now and talk more about what we've been working on, and that's graphing. Of course, we graph on something called the what, class? Cartesian plane or coordinate plane. It consists of 2 number lines called the vertical, or up and down, axis is called the y-axis, and the side-to-side or horizontal axis is called the x-axis. They intersect at a point called the origin. What's the value of the origin? 0 on both x and y. Speaking of which, every single point on the Cartesian plane has a specific x value, and every point also has a specific y value. The x value is called the abscissa. The y value is called the ordinate. And if we put them together, we have the points. Coordinates. Good. Did somebody say coordinate a minute ago again? No, we're just laughing at Maddie all over again. It's a rough life. You make one small mistake. You do a great job every other day. Sorry, Maddie. All right, but abscissa, ordinate, coordinates, the exact location of the point. The Cartesian plane is divided into 4 sections called quadrants. Remember, the bottom right quadrant is quadrant 4. Top right quadrant, 1. Bottom left quadrant, 3. And top right quadrant, 1. I'm mean, I know. We said that most of our graphing, beyond just plotting something, plotting points on the Cartesian plane, extends to drawing lines or graphing lines. Lines come from equations that have both x and y to the first power called linear equations. And most linear equations will cross the axes at some point. Suppose if it's a straight up and down line, it would only ever cross the x-axis. Side-to-side line, horizontal line would only cross the y-axis. But most lines, they'll eventually cross both axes. And the points where they cross the axes are called intercepts. Of course, where it crosses the x-axis is called the x-intercept, and where it crosses the y-axis is called the y-intercept. Good. These linear equations, these lines that we graph, have a particular slant to them, but we don't call it slant, we call it, because it sounds cooler, slope. And we said slope is defined as a fraction. What over what, class? Rise over run. And if the line rises and runs to the left, we have a line with what kind of slope? Negative slope, right? It would look like this. If we have a line that rises and runs to the right, that would be positive slope. If we have a line that runs but never rises, right? Never rises, only runs, that's 0 slope. And of course, if it rises and never runs, we have undefined slope. That vertical line has the undefined slope. Of course, the vertical line then typically would have only an x-intercept, not a y-intercept. We talked about different ways to graph linear equations. We said the most basic method is by setting up an XY table and just figuring out some points, plotting them. We could do that. We also said we could calculate the intercepts. When you calculate an intercept, you're going to plug in what number for each letter? 0, because an intercept is where there is a 0. When it crosses the x-axis, all points on the x-axis have a y value of 0, because from the origin, it never rose, it just ran. And so the y-intercept, of course, would have an x value of 0, an abscissa of 0. And we talked about all of that. Clear desks. Let's take a quiz. Y'all are like, what? A quiz? I'm shocked. Quiz 19. You'd only need a blank sheet of paper. It does not have to be graph paper, but your paper is for a cover sheet. Don't write anything on the blank paper. Blank paper for a cover sheet. You're actually going to take the quiz on my quiz copy for a change. You can use that. All right. I would recommend a straight edge calculator if it makes you feel good, but you really probably don't need one. But I recommend a straight edge, even if it just involves a piece of paper you fold a few times. I do sell straight edges for 25 cents. That means I fold the paper a few times for you. Sheet of paper, pencil, calculator, you probably won't need it, but maybe it makes you feel good. Straight edge for sure, you'll want. All right. Oh, hold on. Whoa. You don't need this right now.
Totally gonna see it.
No, you don't need that. That doesn't need to be up here. Probably don't need the other one either. Yeah, you don't need that. No, indeed. All right. Just so that way there's no unfair advantage for students in the classroom.
I
Like
think
people on
our
YouTube.
homework is giving away answers.
Probably, but I'm going to leave it up there anyway. All right. When you get your quiz copy, put your first and last name in the name spot and today's date in the date spot. First and last name in the name spot and today's date in the date spot. Today is 1/7/22. 1/7/22. Today's date. Let's take a look at the quiz together very quickly. I'm going to go and end the video here for part 1. We'll restart the video once the quiz is finished. Number 1, it says label the axes. Okay, so set up the grid. Remember I said whenever you do a graded graph, you better do some certain things to, do it. Plot those points. Make sure you label the points. Number 2, you're going to tell which points or which quadrant each of those points are in for A, B, and C. I won't ask about D. For numbers 3 through 13, you're going to answer some questions, some terminology that's being asked. And then number 14, I've given you an equation. You could do it one of 3 ways. It's entirely up to you which way you choose to graph it, but graph it. Show the work there at the bottom of the paper. There should be enough room for you to show your work there at the bottom. Today is 1/7/22. All right. Keep your work covered with your cover sheet.